Number 1, it says find the missing side of each triangle, round your answers to the nearest tenth. So I've got a right triangle and I'm missing one side. So if that's the case, I'm going to use Pythagorean theorem. A squared plus b squared equals c squared. Which one is always my c? Across from the 90, what is that called? The hypotenuse, right? So that's my c. And I've got a and b. Remember, a and b is just, doesn't matter which leg you put each one on, just the other two are a and b. All right, so let's plug into it. So I've got 12 squared plus x squared, and then c is 16 squared. 12 squared is 144. Bring my x squared down. And then 16 squared is 256, right? Okay. All right. Then we're going to subtract that 144 because we're trying to get x by itself. And x squared is equal to, was that 112? Is that right? All right. And then last step, how do I get that squared off that x? Square root it. And x is equal to 10.6. So I highly recommend with this, like Pythagorean theorem, most of y'all did really good during this section. Okay, really, this is my test taking strategy. Is I would really study hard the ones that like you understand, like the easier stuff like this. Make sure you have it down to where you don't make a mistake and miss like the easier questions like this. Okay, and obviously you want to study the harder stuff, but I would put more effort into making sure you know this. That way, when you get your test, you get as many points as possible by getting the easier stuff, and you're not messing up on it. State if each triangle is a right triangle. So when we do this, once again, we're going to use Pythagorean theorem. But we're going to plug everything in. When I plug everything in, how do I know if they are an actual right triangle? What are they going to be? What is each side going to be with each other? Equal. Okay. So to be able to plug it in, I need to figure out which one is my c. Which one is the largest number? Well, they gave me radicals on 2 of these, so it's kind of hard to tell. And they didn't tell me for sure which one's the right angle. Looking at it, it should be pretty obvious which one's the right angle, or which one's the closest to it. But let's not assume they drew the triangle correctly. So what I would do is take the square root of 122 and the square root of 222. So somebody do that real quick and let me know what you get.
Is 11.04. So 222 is 14.89.
Okay, so 14.9. All right, so we have 11.0, 14.9, and 10. So which one's my C? The 14.9. Okay, so it's going to be C, A, B. Okay. Now when you actually plug them in, use the radicals. Don't use the decimal. We just found the decimal just to figure out which one was actually the biggest number or the largest number. So I'm going to plug in for A, put in parentheses square root of 122 squared. B is 10, and then square it. And then C is the square root of 222 squared. All right, does anybody remember when I square a square root, what happens to that square and square root? They just cancel. So if I have a square root of 122 and I square it, it's just going to become 122. The number inside, like the box, the radical and the square just cancel each other, and we're just left with the number inside. Okay? But then the next one is 10 squared, which is 100. Then the square root of 222 squared is 222. Then we add these up. And obviously they do equal each other, so the answer is yes. They do form a right triangle. I'm going to work 7 and 8 with you. So these say find the missing side lengths, leave your answers as radicals in simplest form. Now these are ones that are harder. Okay? A lot of students struggled with this section. Mainly because I think you had to leave your answers in radical form. But these are your special right triangles, 30, 60, 90, and 45, 45, 90. So let's write down the formulas for those. 30, 60, 90. The formula was hypotenuse is equal to short leg times times 2. And then it was longer leg is equal to shorter leg times the square root of 3. So there's your formula for 30, 60, 90. And don't forget, I'm going to give you the formulas. So don't freak out like you have to memorize these. But then the 45, 45, 90 was hypotenuse. Hypotenuse is equal to leg times square root of 2. Okay, it just had one formula. When I look at number 7, is that at 30, 60, 90 or 45, 45?
30, 60, 90.
30, 60, right? They had a 60 in there and a 90, so this other one's obviously going to be 30. Okay? So on a 30, 60, 90, remember you have a shorter leg, a longer leg, and a hypotenuse. The shorter leg, do y'all remember which angle it's across from? Across from a 30-degree angle. Remember, the smallest number is going to have the shortest leg. So that's the shorter leg. Across from the 60 is the longer leg. And across from the 90 is always what?
Hypotenuse.
Hypotenuse. All right, so I know I'm going to use both of these formulas. Hypotenuse is equal to short leg times 2. And longer leg is equal to shorter leg times square root of 3. Every time you solve these, you're going to have two answers, and you use both of these formulas. So I have to start out with asking myself, like, what information did they actually give me? And I look, and the only side they gave me was the longer leg. So start with that formula, the longer leg formula. So we'll do this one on the right first. Plug in for longer leg. That's 3 square root 6 over 2. Is equal to the shorter leg is y times square root 3. All right, so we need to solve this. So what I can do is put that square root 3 over, how do I back it up? How do I get that square root 3 to the other side? We divide that whole thing by square root 3 because we need it to the other side. And remember, when you divide a fraction, you just put that number on the bottom that you're dividing it into. So then we rewrite it. Now I've got y is equal to 3 square root 6 over 2 square root 3. We need to simplify here. So when I simplify, y equals, let's ask ourselves, remember you keep the whole numbers together, multiply and divide those, then multiply and divide the radicals. So 3 over 2, can those be reduced anymore? 3 divided by 2. No, that just, it's going to say 3 over 2. Now, square root 6 divided by square root 3, do those divide into each other? 6 divided by 3?
2.
Yes, it's 2, but since they're both radicals, you have to leave it as a radical. So square root of 2. Now, I've simplified my whole numbers, I simplified my radicals, that's my answer. 3 square root 2 over 2. All right, next one. Hypotenuse is equal to short leg times 2. The hypotenuse we don't know, so it's x. The short leg we just found, 3 square root 2 over 2. And then times 2. Same thing, put that, well, not same thing, but this time we put that 2 over a 1 to make it a fraction. So we can multiply. This one's nice. X is already by itself, so I just keep it x on that side. And we multiply the top with itself and the bottom with itself. So when I multiply this, 3 square root 2 times 2. Is there anything that 2 can multiply with on that 3 and square root 2? Is there another whole number? Is there whole numbers?
Yeah.
Yeah, the 3. So that 2 and the 3 can multiply, right? So 2 times 3 is just 6. And just bring your square root of 2. Now the bottom, 2 times 1 is 2. All right, what's the last step we do here? 6 divided by 2, which is 3. And then bring our square root of 2 down. There's no other radicals to combine it with. So that's my answer. So number 8, what kind of triangle is this one? 45, 45, 90. And what do we know about the legs on a 45, 45, 90?
They're all the same.
They're the same. So make note of that. Legs are congruent. Okay. So if you know one leg, you automatically know the other leg. Don't even have to solve for it. So we know we need to find x and y. 2 answers on these. The x is what side, a leg or the hypotenuse? Hypotenuse is across from the 90. So the other 2 must be legs. So without even doing any work, since this is a leg and this is a leg, y is just going to equal the same thing. 9 square root 2 over 2. So go ahead and answer that one. 9 square root 2 over 2. No work to even show on that one. But the other one, I got to use the formula. H is equal to L times the square root of 2. H is x. The leg is 9 square root 2 over 2 times the square root of 2. All right, I can put that square root of 2 over 1 to make it a fraction. Now let's multiply across. I have 9 square root of 2 times the square root of 2. Anything with a 9 to multiply with? No. Just bring it down. Square root of 2 times square root of 2 is what? 2 times 2? 4. So a square root of 4. But the square root of 4 is a perfect square. So what does it end up equaling? Square root of 4 is 2. So I'm going to bring that down times just normal 2. Remember, right. Anytime you multiply 2 radicals with the same number inside, that number just comes out. So if it's, say, square root of 10 times square root of 10, it's just going to equal 10. Because if you think about it, square root of 10 times square root of 10 is square root of 100. Square root of 100 is just 10. Okay? So they'll always just go to the whole number. And then on the bottom, 2 times 1 is just 2. All right, and we solve that out. 9 times 2 divided by 2 is 9. So my x is equal to 9. 15 through 18 says, find the missing side, round to the nearest 10. How many missing sides do I have total? 2. They only want us to find one of them, but we have 2 missing. And they gave me an angle. Does anybody remember how we actually find these? SOHCAHTOA, trigonometry, right? SOHCAHTOA. What a wonderful phrase. Y'all remember that? Okay. I'm not going to make y'all sing it this time. But if it helps you, sing it in your head. Okay? If you want to sing out loud, I don't care right now, just not during the test. Okay? All right, so we're going to use SOHCAHTOA. SOHCAHTOA. Use our reference angle is 36 degrees. That's the opposite side, so the 13 is opposite. The x is right next door, so it's the adjacent. So I'm going to use O and A. Which one am I going to use, SOHCA or TOA? TOA. So I'm going to use tan. Then remember the angle goes here. We're going to put theta for the angle there. Remember theta, just talking about that's you just plug an angle measure in for it. And then it's O over A, TOA. O divided by A. TOA. Okay, let's plug in. Tan of the theta. What does the theta equal? 36. It's just our reference angle. O is how much? 13. And then A is the x. X is on bottom, so what do I do? Divide. So remember that X on bottom? Divide. All right, so when we divide this, we're going to say X is equal to, keep that 13 on top, 13 divided by tan 36. And what does your calculator need to be in? Degrees. So if you need to make note of that, calculator needs to be in degrees. So remember, hit the mode button and check that degrees is highlighted, not radians. And when you plug that in, you should get 17.9. 19, find each angle measure to the nearest degree. So if we're looking for the angle measure, we still use trigonometry, SOHCAHTOA, but these are really nice because they already told me which one to use, which trig function. They said cosine of x. So I'm literally just going to say cosine inverse 0.1045 is equal to x. And you're going to plug that in your calculator, inverse cosine or cosine inverse 0.1045. And when you do it, you should get 84 degrees. It says find the measure of the indicated angle to the nearest degree. So once again, we're going to use inverse trig. If we're looking for a measure, an angle x, this is opposite and adjacent. So I'm going to write out SOHCAHTOA. SOHCAHTOA. We O and A, so it's going to be TOA.
Is this inverse?
Yep. Yeah, if you're ever looking for the angle, use inverse. If you're looking for a side length, use normal trig. So it's going to be tan inverse. Tan is opposite divided by adjacent is equal to the missing angle or the angle, theta. So it's going to be tan inverse. The opposite is 11. The adjacent is 24. And the theta we don't know, so it's x. Now literally just plug that in your calculator. Tan inverse 11 divided by 24. And to the nearest whole number, you should get 25 degrees. All right, 27. We're solving the right triangle. We're finding all the missing sides, all the missing angles. And for our purposes, remember, you'll always just have 3 answers. 2 missing sides and an angle, or 2 missing angles and a side. So on this one, we have 2 missing sides and an angle, and I recommend labeling them X, Y, and Z. They labeled one X for you, so I'm going to call this one Y, and then I'm going to call the missing side Z. So I have, and then I'm going to set out, I got to look for X, I got to look for Y, and I got to look for Z. All right, X is a missing side. So they gave me an angle measure in one side, so I can use trig to find the other one. Bless you. So if 66 is my reference angle, 19 is my adjacent, and the X is the hypotenuse. Bless you. So that's A and H. SOHCAHTOA. Which am I going to use if I'm using A and H? Ka. So it's going to be cosine of the angle 66. The A is 19, adjacent, and the hypotenuse is X. X is on bottom. Do I multiply or divide?
Divide.
Divide. So it's going to be X is equal to 19 divided by cosine 66. Tell me what you get when you get that. Good. 46.7. And then Y is the missing angle. Bless you. What does all 3 angles inside a triangle add up to equal? 180. So if they gave me 2 of them, I can add them together and subtract from 180, right?
Yes.
If I didn't know, if I was missing 2, I would use inverse trig. But since I have 2 of them, just add them together.
24.
90 plus 66 equals 156, and 180 minus 156 equals 24. So y is 24 degrees. And lastly is z. So I know I found the other side. So if I have two sides and I'm missing one, what could we use? Yeah, Pythagorean theorem. A squared plus b squared equals c squared. You could use that, or I'm going to show you the trig way, if you'd rather just use the trig way. So the 66, the 19 is A, and then I got to find Z. So that's my opposite. So O and A is TOA, tangent of the 66. Opposite is Z. Adjacent is 19. Z's on top. Multiply or divide? Multiply. Z is equal to 19 times tangent 66. And what do you get when you do that? 42.7. And there's my three answers. It says determine if line AB is tangent to the circle. Okay. So AB is this line right here. And remember, a tangent line just intersects the circle in how many spots? One point. Okay. So it's just going to kind of glance off of it. So it says to determine if this is tangent. If it is a tangent line, what kind of angle does it make with the radius?
90.
A 90. Okay. So what we need to do is use Pythagorean theorem. A squared plus b squared equals c squared. To determine, does this actually form a right triangle or not? If it does, then that means that it's a tangent. If it doesn't, then it's not. Okay. So I have that maroon side, also have this blue side, and I have the green side. Okay. Now let me ask, how long is the green side? The green side is 14. From here to here is 14. Because remember, from here to here is 5.6. Okay. So what's this length from this point to this point? 8.4, because it's a radius just like that one, right?
Yep, I didn't know that.
So that's 8.4. So what you'll do is add up 5.6 and 8.4, and that gives you the total. Remember, if they just give you a number like 5.6, and it's just that little length, like unless they tell you it's the full length, don't assume it's the full length. Okay. All right. So which one is my C? 14. And then the other two are A and B. So I'll plug it in. 8.4 squared plus 12.8 squared equals 14 squared. So 234.4 on this side. And 14 squared is 196, right? Do those equal each other? No. Put a slash to the equal sign. Those do not equal, so they're not tangent. Number 3 says, find the length of the radius. Assume that lines which appear to be tangent to the circle are tangent. Okay. So the ones that appear to be tangent, that would be this one right here. If that's tangent, what kind of angle does it make with the radius? Yeah, 90. So if that's tangent, that means that that's a 90-degree angle there. So what kind of triangle is this? Right triangle. And we're missing one side. We can use Pythagorean theorem again. And which side is my C? 15.5 is the one across from the 90. And the other two are A and B. So that's going to be 12.4 squared plus, we don't know B squared equals 15.5 squared. So once this is solved all the way out, B gets to 9.3. Number 5 says, find the measure of the indicated arc and then tell whether it's major, minor, or semicircle. Assume that lines which appear to be diameters are actual diameters. Okay. So that's really key. Assuming that the ones that appear to be diameters are diameters. So a diameter goes across it and goes through the center. So there's a diameter. That looks like one. And there's one. And a diameter literally cuts the circle in half, right? So if it cuts the circle in half, how much is each side? How many degrees? 180. Because a total circle is 360. So that means, like for example, this half on the orange would be 180. This half would be 180, right? Or I could say, all right, that half is 180 and that half is 180. So keep that in mind. So what I recommend when you do these, I know we're looking for arc EF. This is the one that we don't know. But I would start out with the ones you do and just work around and find the ones that you can until you get around to the one that you're looking for. So, for example, we start at the 122. 122 is right here, CG. Well, I know this whole half here underneath this orange is 180. So, how can I find what FG is if I know CG? Yeah, so because this whole thing here is 180, I can say 180, and this is step 1, minus 122, and that gives me 58, which is FG. So now that one's 58 there. Same thing for CD, yep. I can do 58 degrees here. Just curious, what kind of angles are these right here from each other that form an X and they're across from each other?
Row 1, column 1. Wi-Fi error, button, user, button.
These are vertical angles because they form an X and they're across from each other. So if this is 58, this is 58. So that's something to keep in mind as well. Okay. So now, how am I going to find X? So they say that this is 58, this is 53, and we said all of this up here is 180. Those three add together equal 180. So I can take, this is my second step, 58 plus 53, which gives me 111, and then subtract that from 180. What's that going to be, 69? So EF is 69 degrees. Yeah, and this is a minor arc. Less than 180. All right, so we got to write this equation, the circle. So let's write out the standard equation. X minus h squared plus y minus k squared equals r squared. So we need the center and the radius. So what I'm going to do is go over to my circle and find the center. Looks like it's about right there. The way I can check is to see if the radius is the same each direction. If it is, then it is truly the center. So I go up 2, I can go right 2, I can go down 2, or I can go left 2. So that is my center point. So what is the actual point on this? Like, what is the coordinate point there at the center? -4, -3. So that's my center. -4, -3. And what letters represent the center? H and K. So make note of that above it, H and K. Now then, what is my radius of this circle? 2. Could I go 1, 2? So my R is equal to 2. Why is R not 4 on this one?
Because that's the diameter.
What's the diameter? But I'm saying, like, why didn't we count, like, each little square? So yeah, the halves, the little squares are counting by halves. So make sure you always, like I said, once again, pay attention to how they're counting. All right, we have the center and the radius. Now we just simply plug it into the formula. Leave x and y alone, so it's x minus, the h is -4, so x minus -4 squared, plus y minus, the k is -3 squared, is equal to, the radius is 2, and we're going to square it. And the last step, simplify. X minus -4 becomes x plus 4 squared. Y minus -3 becomes y plus 3 squared, and 2 squared is simply 4. And that's my equation. 17 says find the circumference of each circle. Use the pi button on your calculator and answer to the nearest tenth. So the 3 there, is that the radius or the diameter? This is a radius, right? So I'm going to use the circumference formula that has radius in it, 2 pi r. Let's plug it in. Circumference is 2 pi times 3. And circumference is 18.8 when you do that. 23 says find the radius of each circle. Use your calculator's value of pi and round your answer to the nearest tenth. So it gave me the circumference, but it wants radius. So you have to look at your key words. I was given circumference, and I need to find the radius. So I'm going to use the formula that has circumference and radius in it. So C is equal to 2 pi r. Now they told me the circumference is 69.1, so do I plug that in for C or for R? C. So 69.1 is equal to 2 pi r. Now I need to get the r by itself because I'm looking for it. So I need to solve for it. So what's my next step?
Divide by 2 pi.
We're going to divide it by 2 pi. That way those go away. Now remember, when you do this in your calculator, the 2 pi needs to be in parentheses. 69.1 divided by parentheses 2 pi. If you don't, the order of operations will get mixed up, and it'll divide it by 2, then multiply the pi instead of dividing it all by 2 pi. And then what do you get when you plug it in?
11.0.
11.0. And there's my r. So yeah, the answer on number 28 shouldn't be 254, it should be 254.5. 25 says let's find the area and use your calculator's value of pi. So the area formula is pi r squared. So 4 is the r because it only goes halfway across. So area is equal to pi 4 squared. You just literally type that right in your calculator and you'll get 50.3. 29 says find the radius of each circle. Use your calculator's value of pi. So the area is 254.5, and it wants us to find radius. So I'm using the formula that's got area and radius. Area is pi r squared. They told me area is 254.5, so I'm going to plug in 254.5 for the area. And we're still looking for the r. So r. So I was given the area, and I'm looking for r. What's the first step I need to do here? Yeah, divide by pi. So I'm going to divide each side by pi, get it to the other side. When you divide just by pi, you don't have to use parentheses if it's just pi, only if it's 2 pi. So what do you get when you do 254.5 divided by pi?
81.0.
81.0 is equal to our r squared. All right, now r is still not by itself. What does it have on it that we need to move?
That's square root.
Well, it has a squared, so we're going to square root it, right? And whatever you do on one side, you have to do on the other, so we're going to square root it. So r is equal to how much? Just 9. And that's it. So it says find the missing side lengths, leave your answers as radicals in simplest form. So number 6 is a 30, 60, 90 triangle. So remember, we have 2 formulas we got to use with that. We have hypotenuse is equal to short leg times 2. Then you have long leg is equal to short leg times square root 3. And remember, on 30, 60, 90 triangles, you always have to do both formulas to find the 2 answers you need. So let's label our triangle. Across from the 30 is always a short leg. 60 is long leg, and across from the 90 is the hypotenuse. So right now we have the short leg. So the short leg's in both formulas, so it doesn't matter which one we start with then. So we'll start with the hypotenuse. Hypotenuse is x. Short leg is 5 over 2. And then times 2. And then 5 halves times 2 gives you 10 over 2, which is just 5. So x is equal to 5. And then on the other one, The long leg is y. The short leg is 5 over 2 times square root 3. And I can put that square root 3 over 1 if it's easier to see it like that. Then multiply across, you get 5 times square root 3. And you can't combine them, so you just put them right next to each other since you're multiplying. And then the bottom, 2 times 1. There's no radicals to reduce because there's only 1. And then 5 over 2 doesn't reduce, so it's just 5 square root 3 over 2. Leave your answers as radical simplest form, okay? So we got to find x and y on number 2. Well, you see it's a 60 degree and a 90 degrees in there, so we know that's got to be a 30, 60, 90 triangle. Okay? So when you have a 30, 60, 90 triangle, remember you have two formulas you have to use. One is hypotenuse is equal to short leg times 2. And then the other one is long leg is equal to short leg times square root 3. So the next thing I want to do is label my triangle. So across from the 90, hypotenuse. Across from the 30 is short leg. Across from the 60 is a long leg. Always remember, across from the 30, that's the smallest number, so it's going to be the shortest leg. And across from the 90 is always the hypotenuse. Okay. So the one they gave us to work with, start out with, is the short leg. And if you look in both formulas have the short leg in it. So it doesn't matter which one I start with. So I'll just go in order. The first one there, hypotenuse is equal to short leg times 2. Plug in. The hypotenuse right now is x. The short leg we found is 4. And then just bring down the times 2. And then just solve it. 4 times 2 is 8. And that one's finished. Then go to the other one. Long leg is equal to short leg times square root 3. Right now my long leg is y. My short leg is 4 times square root 3. So remember, when we're multiplying this, if they want you to leave it into the simplest radical, we're not going to multiply the number with the radical. So if you're multiplying, just put them right next to each other. So just 4 square root 3. And that's it. Number 7 says, find the missing side round to the nearest tenth. So I have an angle, and I have one side, and I'm missing another. So on these, one use trig, SOHCAHTOA. Across from the 15, that's opposite. And across from the 90, that's the hypotenuse. So it's going to be SO. Remember, if we're looking for a missing side, we're going to use normal trig. Okay? So it's going to be sine of the angle, theta, is equal to sine is opposite divided by hypotenuse. So it's sine of 15 is equal to opposite 16 divided by hypotenuse x. If x is on bottom, remember we divide. So x is equal to 16 divided by sine 15. So make sure your calculator's in degrees and do that. 61.8. Which says, find the segment length indicated, assume that lines which appear to be tangent are tangent. Okay. So if they appear to be tangent, that means they're just going to intersect right on the edge. So that's going to be like this one right here. And if they're tangent, they're going to make a right angle with the radius. Okay. So that one is, the radius is 12. This one's 16. We're looking for this one right here. Okay. Well, I know that from here to here, from the edge to here, that's just a radius, right? And they gave me one of the other radius. So this is going to be 12. So I need to find this x here. Okay. Well, what I'm going to have to do is find that whole length, and then I can subtract that whole length by 12 to figure out what x is. So since it's a right triangle, I can use Pythagorean theorem. And this is going to be my c because that's across from the 90. And then we'll just do a and b. So a is 12 squared. Then b is going to be 16 then squared. And then c is just going to be c squared. We don't know what it is yet. So 12 squared is 144. 16 squared, is that 224? Yeah, 256. And then c squared, we still don't know. Add those two together, what do you get? 400 equals c squared, and then we have to square root it to get c by itself, and c is equal to 20. Okay, so c equals 20, but that's the whole length there. I just need that little length from here to here. So the whole thing is 20, So I'm going to do 20 minus the 12, and it gives me 8. So x is equal to 8. Number 12 says, find the measure of the indicated angle to the nearest degree. All right, so we're looking for an angle, and we have two sides on this right triangle. So remember when we're doing that, we're using trigonometry. So we're going to do SOHCAHTOA. And so I'm just going to put an X for the angle, because that's the one we're looking for. Now remember, if I'm looking for an angle, I have to use inverse trig. Okay, if you're looking for a side, it's going to be normal trig. So I have the angle there. The 22 is my adjacent, it's right next to it. And the 23 is across from the 90, so it's my hypotenuse. So I have O and A. So, A and H. So it's C. So it's going to be cosine inverse. Remember, cosine is adjacent over hypotenuse is equal to the missing angle, the theta. Plug in. Cosine inverse. My adjacent is 22. My hypotenuse is 23. And we don't know the angle, it's x. And then you just put that in your calculator. Now you have to make sure your calculators are in degrees. So double check your calculator, then plug that in. X is equal to 17 degrees. As I said, round to the nearest degree, so it wants a whole number. Find the segment length indicated. Assume that lines which appear to be tangent are tangent. Okay. So the line that appears to be tangent is the one that's going to graze across it and just intersect the circle on one point. So it's that 7.5. Okay. So if it's a tangent, that means it makes a right angle with the radius. Now, mind you, that 5 is just from here to here. That's the radius. So the other one's going to be 5 as well. So what's the whole length going to be? 10. Okay, so I'm going to use 10. And I'm going to use Pythagorean theorem because it's a right triangle. A squared plus B squared equals C squared. This is my A, my B, and this is my C because it's across from the 90. So 10 squared plus 7.5 squared equals C squared. Do it in your calculator. 10 squared plus 7.5 squared. Tell me what you get. 156.5? 45? Oh, 25? So basically 156.3. C squared. And the last step is we're going to take the square root. When you square root that, what do you get to one decimal place? 12.9? Oh, 5. And that's my C. It says find the measure of the indicated angle to the nearest degree. So 14. So you're looking for an angle, and they give you two sides. So remember, if you're looking for an angle, that's inverse trig. So it's SOHCAHTOA. If you're looking for a side, and they give you an angle, and in one of the sides you can use trig, normal trig. But if you look for the angle, use inverse trig. Okay. This one is the adjacent next to the angle. This is the hypotenuse. So it's A and H, so it's cut. So it's going to be cosine inverse of A over H is equal to theta, the missing angle. So cosine inverse, the A is 10, the H is 22, the theta we don't know, so it's X. All right, so X is equal to 63 degrees. Okay. On 20, we're finding the missing side again. So this is a radius right here. So this one right here is also a radius, so it's 11.7. And this whole length here is going to be what? That'd be 18. Is it 19.5? Double check my. What is it? 19.5. And then this is my right angle right here where the tangent goes and hits the radius. So it's a C, A, B. Use Pythagorean theorem. 11.7 squared plus B squared equals 19.5 squared. And then when you solve for B, 6. 25 says identify the center and radius of each, then sketch the graph. Okay? So remember, the center and radius, center is equal, the points are HK, right? On your formula, the H and the K are right there. So when you do the center, remember you flip the sign because the original formula is negative. So you flip the sign. So if it's negative 3, it's positive 3. K is positive 3 because you flip that sign. So the center is 3, 3. And then you need to remember to find the radius. That 16 is r squared. So we take the square root of 16 and you get 4. So r is 4. Then you just plot it. 3, 3 is right here. And then your radius, you go up 4, right 4, down 4, left 4. So 1, 2, 3, 4. 1, 2, 3, 4. So like that, and then you just draw the circle. Hopefully your circle looks better than mine, but that's it.